It's a very common ailment in the IT that encourages a team or an organization to chase after newer and more modern trends over the tried and true. It's like a child running after a new shiny object just because it's new and shiny. It's not necessarily a fatal approach, but it does hold back enterprises, especially those with DevOps initiatives, from realizing their full potential. And nothing exemplifies this better than your regular, humble, neglected mainframe. Hi, all. I welcome you to this Mainframe DevOps session. Today, we are going to talk about mainframe in enterprises and how to integrate it with DevOps for the enterprise to get the most out of it. But before we begin, let's look at our agenda for today. So first of all, we're going to discuss a little bit about mainframe. We're going to introduce ourselves to mainframe, followed by certain pitfalls that come along with mainframe. Then we are going to discuss why is mainframe so crucial in an enterprise and why companies continue to use the mainframes despite the challenges that come along with it. Then we're going to talk about executing CI/CD on mainframe or DevOps on mainframe and what comes out of it. Then we are going to look at how to approach DevOps or how to do DevOps on mainframe. We are also going to look at the use case of Infosys, which has done this extremely successfully over the past few years. And finally, we are going to discuss certain mainframe DevOps tools that we think are absolutely essential for a company to invest in for this approach. With that, I come to the end of my agenda. Kindly take up this time to subscribe to us and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, if you want to learn about the various concepts in DevOps, along with tools and technologies that are encompassed in it, don't forget to check out our DevOps certification training, the link to which I'll leave in the description box below. So without much ado, let's get started. So what is a mainframe? So mainframes are basically data servers which are designed to process large amounts of data transactions daily with the highest levels of security and reliability. At their core, mainframes are high performance computers with large amounts of memory and processors that process billions of simple calculations and transactions in real time. Now, mainframe is critical to commercial databases, transaction servers, and applications that require high resilience, security, and agility. Although the term mainframe first described the physical characteristics of early systems, today it can be best used to describe a style of operation or applications and OS facilities. Today, computer manufacturers don't always use the term mainframe to refer to mainframe computers, which most of you might already have thought while getting into this session. Instead, most have taken to calling any commercial use computer, large or small, a server, with the mainframe simply being the largest type of server in use today. We are going to be using the term mainframe in this session to mean servers that can support thousands of applications and input-output devices to simultaneously serve thousands of users. Servers are proliferating, and a business might have a large server collection that includes transaction servers, database servers, email servers, and web servers. Very large collection of servers are something known as server farms. The hardware required to perform a server function can range from a little more than a cluster of rack mounted personal computers to the most powerful mainframes manufactured today. So, a mainframe here is the central data repository or hub in a corporation's data processing center. It is linked to users through less powerful devices such as workstations or terminals, and the presence of a mainframe often implies a centralized form of computing as opposed to a distributed form of computing, which we see in more modern settings today. Centralizing the data in a single mainframe repository saves customers from having to manage updates to more than one copy of their business data, which increases the likelihood that the data is current. Now, obviously, such a huge responsibility will come with its own set of challenges, and most of these challenges could be clustered more or less into three primary challenges. Firstly, you have quality challenges, which includes difficulty in reproducing production defects, which often takes a long time to fix. Apart from that, there is poor test coverage due to lack of automated testing. Second, you have release challenges, which is pretty obvious due to the difference in the development and operational environments and limited automation. And finally, you have process challenges and culture challenges, which occurs due to point-to-point, ad hoc, and fragile integration of tools, poor visibility, scalability, and extensibility, cultural barriers which limit collaboration, as well as a heavy-handed control of dev environments. Now, by no means I wish to say that today's mainframe is ill or in its deathbed. In fact, it's far from it. But it's been largely neglected by the DevOps community. But why so? Is it because mainframes have limited release cycles, limited automation capabilities, and limit on build and deployment that somehow affect how quickly the business can implement change and realize value from it? That's pretty much the case. But you need to understand that mainframes are critical to the enterprise. In fact, if your organization wants to continue to provide solid, reliable services to its customers, it needs to invest in its mainframe and those responsible for maintaining it. And there are several reasons why businesses today rely on the mainframe. Firstly, they perform large scale transactional processing, which is literally thousands of transactions per second. Domains such as banking and finance and government statistics heavily rely on these aspects. Apart from that, it supports thousands of users and application programs concurrently accessing numerous resources. They also manage terabytes of information in databases and handle large bandwidth communication. Most of today's busiest websites store their production databases on a mainframe host. And the new mainframe hardware and software products are ideal for web transactions because they are designed to allow huge numbers of users and applications to rapidly and simultaneously access the same data without interfering with each other. The security, scalability, and reliability is critical to the efficient and secure operations of contemporary information processing. And that is why there is no way that mainframe is going out of fashion for any time soon. So, what is the solution? The solution is DevOps. First, though, let's make clear of what DevOps means. Very briefly, DevOps is what you get when you break down the barriers that have traditionally separated developers from the IT operations folks. So that's the dev people and the ops people. When these teams work in isolation from one another, lack of communication and coordination between them can lead to inefficiencies and delays. Since the people who write the code are out of sync with the colleagues who deploy and manage it, development cycles are slower, quality analysis is more difficult, and deployment is delayed. So, the goal behind the DevOps movement is to enable continuous integration and delivery, which means the software is designed, written, tested, and deployed to the end users on a near continuous basis with no kinks or delays in the pipeline. This is something known as CI/CD or continuous integration and continuous delivery, which benefits everyone pretty much. It makes developers and admins' jobs easier, it delivers application updates and enhancements to its users faster, and it reduces time to value for organization. DevOps also emphasizes agility, which means the ability to scale applications and switch between programming frameworks way easily. So let's look at how executing CI/CD on the mainframe is beneficial for a company. Now, DevOps obviously improves time to market for mainframe applications by bringing the development and operation teams together for development. With automation, this culture change plays a key role in shortening the development lifecycle and ensuring a better quality product. It also brings up validation tests earlier in the development lifecycle, helping developers to better filter out and correct bugs during the development process. You can use cutting edge integrated development environment or IDE tools for DevOps to assist the CI CD and to help organize achieve true automation on the mainframe. These tools will help you deliver high quality code and provide early defect detection by enforcing automated code review rules, automated unit testing, code coverage testing, continuous integration, and automated deployment. Additional features such as auto-completion, real-time syntax checking, and offline compile greatly increase the developer productivity. These tools can aid developers with a pictorial view of flow in analysis across multiple programs and can provide an overview of data movements in variables, identify unused variables, dead code, and even more. These tools don't just help on the mainframe. You can also use them to assist with the deployment process for distributed applications while addressing dependencies and fostering better collaboration. Virtualization is another thing that can help your mainframe immensely. DevOps teams can use it to speed up testing life cycles and provision testing regions faster. Bringing virtualization to mainframe testing helps reduce your dependencies on test region availability, which is at a premium in mainframe systems today. It also means the testing cycles will take less time and even cost less. Thankfully, there is an approach which makes marrying DevOps and mainframe investments possible. So, how do you actually integrate the two? Making a connection can be a little difficult as the DevOps centric approach is a big cultural jump. But a phased out approach to DevOps is probably the safest way to do so. Digital transformation demands smarter software delivery and new ways to engage with customers. You need to try to achieve agility without disrupting your core business processes. Certain things are for sure. First, adopt a test everything strategy using continuous integration build approach with preferably automated self-validating test builds. So look at what is possible based on your current code base, start small and quick, build to more complicated test setups, validate your core functionality first, progress to the edge cases and error conditions, refactor your code base and improve testability. Next, unify your mainframe application asset change management to make orchestration easy. Basically, what I'm trying to say is make version, track versions, and plan it all. So version everything, package everything, and define a pipeline. Enterprise applications have thousands of disparate parts, currently maintained in separate systems, limited linkage between systems for application dependencies, and missing assets and information is rampant. DevOps practices force linkages, automation, and standardized packaging. Next, document standardized environments and drive cloud provisioning of isolated mainframe images and applications based on standards. So automate, instrument, and audit. So standardized topologies that exist and automate the deployment of the complete system. Create standardized environments for your deployment. And finally, optimize your orchestration. This should include dependency virtualization and test data conditioning. So create targeted small subsets faster and more efficiently than cloning. Compare to pinpoint and resolve your application defects much faster. This will also improve your development efficiency. Creating the right sized target test environments saves storage costs and speeds testing by a lot. So in short, automate everything, version everything, test everything, track everything, audit everything, and dashboard everything. And you don't have to go just all in. Experts recommend a phased approach to implementing DevOps on the mainframe. You can start by leveraging existing tools and products in your mainframe environment to implement your CI/CD services. This is the least intrusive and most cost-effective approach as well. Then you can go ahead, select and provision the best suited tools based on your mainframe landscape, business strategy, processes, so on and so forth for implementing the CI/CD cycle completely. Once your DevOps maturity level has increased, the culture shift has happened in your company, your project scope can be broadened from just CI/CD to include other aspects of the DevOps cycle as well. So a great example of this is Infosys, which has developed a lighthouse program in accordance with its consultation team that defines the CI/CD processes specific to mainframes. This has enabled it to shift from the traditional waterfall approach to new ways of working. Now, this accelerates the DevOps adoption in client organizations through progressive transformation through three things: technology, process, and people. It brings in technology innovation with robust automation across the IT value stream. It processes transformation using lean and agile practices and people transformation through an integrated team model. Infosys has established CI/CD processes specific to mainframe and used it to increase agility and time to market, improved quality, and simplified processes through automation. Infosys used DevOps on the mainframe to speed up time to market for its mainframe applications. All it took was a change request to get DevOps to play a pivotal role. DevOps on the mainframe now could migrate mainframe test environments to distributed test environments. The target regions could simulate a mainframe environment and address region unavailability issues that were typical with mainframe projects earlier. In doing so, teams at Infosys could complete the test region provisioning and virtualization faster, which reduced the development cycle times for test regions. This in turn reduced the time and money required for the mainframe region provisioning and the testing. And they also use different test data management tools for their data on the simulated environment. But this obviously could not have happened without the use of powerful tools which you will need for your company to meet their digital demands. So, now I'm going to talk about the primary DevOps tools that you should be using on the mainframe and across platforms, along with certain examples and some of their primary open system integrations. So, first of all, you have a planning and collaboration tools. Now, you should continually collaborate with both your mainframe team and across platforms throughout the DevOps lifecycle, and that is no surprise. These tools enable mainframe and distributed systems to both plan and discuss architectural approaches to projects and document those processes to provide feedback. Certain examples of these are Confluence and Slack. Then you have analysis tools, which form the foundation of the entire DevOps process, spanning all the key assets, whether code configuration, documentation, databases, compiled resources, or your website. You can only improve by managing them as one source of truth. From there, everything else can be built when required. On the mainframe side, you need to understand the code quickly to plan your changes. So, do impact analysis and manage your backlog. So, when it's time for code review, the analysis helps again. A good cross platform analysis tool will provide quick feedback to developers regarding the program flow, structure, and potential code quality issues. A couple examples of those are Topaz and SonarLint. Next, you have your source code management tools, which are probably one of the more popular set of tools in DevOps. So, in DevOps, multiple people need to be able to work on the same program because DevOps is fundamentally a philosophy that hinges on faster delivery. Therefore, your mainframe team needs an SCM tool that enables concurrent development, enables faster changes, and is capable of supporting post build activities like automated testing via REST APIs. Your SCM tool should be open in that it links into the entire DevOps toolchain, so it cannot be siloed. It must integrate with open source DevOps tools such as Jenkins and Zabbia Labs, certain examples of which are GitHub, Bitbucket, and GitLab. Next, you have your build tools. Now, you don't need the build holding you up when you're ready to deploy, right? It has to be fast and accurate. Also, it needs to be traceable. So you need it to run from APIs that provide visibility into what's occurring on the mainframe so anyone can run and monitor and deploy without having specialized knowledge about mainframe technologies. Your build tool should basically be helping you get your application ready to test and deploy to a production faster. One such tool is the ISPW. Next, you have your automated testing tools. Now, as we all know, manual testing is incompatible with DevOps. It will slow you down and leave room for negligence or mistakes, both of which reduce the efficiency and quality of your product. Automated testing tools verify code quality after the build before it's promoted. The quicker the feedback loop works via automation, the higher the quality gets and the quicker you reach the desired definition of done. Selenium and Test Complete are two examples of such tools. Next, you have your continuous integration tools, which is another very popular category of tools in DevOps because these tools provide an immediate feedback loop by orchestrating build and testing tasks. Teams can merge developed code many times a day, getting feedback from automated testing, quality, security, and other tools to ensure quality and continuous feedback. A very popular example of this is Jenkins. Next, you have continuous deployment tools, which in an effective DevOps environment are needed in close frequencies as application deployments are quick, predictable, and reliable. This continuous delivery means applications can be released to production at any time while keeping risk as low as possible. Now that you have reached a point where your mainframe code is being developed faster, it needs to link with the distributed components delivery as well. So these components increasingly rely upon each other, and therefore their deployments must be coordinated. Having one dashboard, one place to manage these deploys, even though they are on different platforms, becomes extremely crucial. Here you have Excel deploy and release, which allow you to automate and standardize complex deployments in cloud, container, and legacy environments. And finally, we have monitoring and feedback tools, because even though you've released your code, you aren't really done, are you? You need something to monitor and check that it's performing well. Here you have tools such as Splunk and ServiceNow to monitor releases so you don't have to, thereby increasing responsiveness and visibility. Now, including the mainframe in your cross platform DevOps toolchain, it's essential to achieving enterprise wide digital agility and improving the innovations through the continuous delivery pipeline. When it comes to DevOps, tools like this will only smooth over the barriers between mainframes and other infrastructure. And it's also essential for achieving maximum agility. Concluding, I'd like to say that all of this is way more achievable than you might think. All you need is a culture change and better collaboration between your development, test, and operation teams. Part of this execution is also knowing what should and what shouldn't run in the first place. Your DevOps teams must acquire the skills and the culture first that they need for this system to work. With the aid of DevOps tools and the right strategy, you can implement a very flexible, adaptable, and incremental approach towards faster and more quality deployments. So I would like to leave you with that thought. My name is Upasna. Thank you and have a great day.